also support this session. So please give a first applause for him. So in this session, we have a very good coverage of topics from Asia and Africa and also Southeast Asia. So we have a special arrangement for this session for favor of time. So let me first invite all the speakers to go and sit in the first row, please. So may I invite Mr. Amin Shakya from Indian Institute of Science of Bangalore. You may take the first seat. Thank you. And may I invite Mr. Ahmad Rashik from Indian Institute of Technology, Patna, India. May I invite Mr. and Ms. Aster Tesfaye Hodova. May I invite Kun Radha Pasisahani from Department of Water Resources of Thailand. And may I invite Mr. Le Xuân Tu from Southern Institute of Water Resources Research, Vietnam. So the session will go on with all the presentations taking place back to back without any interruption in between. And after that, the presenters will come back to this very table, and we will start to take questions at the end of the presentations. So with this, let me invite Mr. Amin Shakya from Indian Institute of Science, Bangalore, India, who will share with us your research in geospatial information knowledge platform for nature-based solutions, recent progress, and a way forward. A round of applause for Mr. Amin.
Hi, Namaste everyone. My name is Amin Shake. I'm currently working as a Senior Project Associate at the Interdisciplinary Center for Water Research, Indian Institute of Science. My collaborators are Dr. Milan, Joy, Dr. Laura, and Dr. Laura and Professor Silvana from CAIO Services and University of Bologna. The topic of the presentation is Geospatial Information Knowledge Platform GeoIKP for Nature-Based Solutions, Recent Progress, and a Way Forward. We are living in a changing climate scenario. With this, we expect increase in hydroclimatic extremes and the amplitude of those extremes as well. Nature-based solutions have been a novel introduction to ecosystem-based approaches. It's an umbrella term that represents blue and green infrastructures, and it can be used in many different stages, such as restoration, protection, but also in infrastructure development and management. Similarly, it has a multi-benefit aspect, ranging from human well-being to biodiversity benefits. The European Union has been leading in the implementation of nature-based solutions, particularly with its European Green Deal, as well as various EU Horizon 2020 projects. In the figure number 2, I have just shown few different NBS implemented in Europe. So we can see NBS implementations around the continent, but also perhaps more importantly, contribution of NBS to various different SDGs, as again, it's an umbrella term and it can mean a lot of things with multiple benefit aspects. Introducing GeoIKP. GeoIKP, or Geospatial Information Knowledge Platform, is a platform for nature-based solutions. This was developed as a component of Horizon 2020 project Operandum, dealing with NBS for hydrometeorological risk reduction. It's more than just a catalog, with NBS catalog being the heart of the GeoIKP, but has multiple other features such as data catalog, where users can get access to NBS related data, NBS toolkit, and geospatial analysis interactive maps, with business networking tools and best practices, policy documents, etc. But more importantly, it's a citizen science-based initiative where we allow people to add contributions of NBS from their regions to the platform. In the end, we have a big repository of various different NBS from around the globe, and we provide a search engine with it. So you can put various criterias of your NBS requirement and filter through it to get best possible suggestions, perhaps, of NBS implementation that has already been implemented at different parts of the world. And again, it's based on Project Operandum and focused mainly on hydrometeorological risk reduction. So when it comes to GeoIKP, currently we have over 500 entries from all over the globe, 31% of which being hybrid solutions, meaning it has some component of gray infrastructure as well as some blue or green infrastructure, 33% green interventions, 10% blue, while 26% blue and green interventions. If we look at the figure at the bottom, we can see 3 case studies from Asia, from Tamil Nadu in India, from Vietnam, and from Madhya Pradesh in India again. And what we also see on the top are the status, whether it's already been reviewed by the moderator or if it's a new entry. At the same time, what kind of intervention is it? So the one on the leftmost corner is mixed, that is green and blue intervention, and so forth. Similarly, in the bottom, we see what all hazards these interventions can tackle. And using all these criteria, we can use the search engine tool in the platform to get customized suggestions in the platform. Here, showing a very small interactive map of NBS focused in the Asia Pacific region. We can already see that we have a lot of entries from the region already. Moving on to materials and methods. So we will be presenting a couple of case studies from Nepal and Thailand, just to give a taste of what kind of information people have added to the platform. Next, we'll be analyzing GeoIKP database for Asian entries, and we try to draw some insights, as well as try to look at some data gaps in the data in the platform. Again, it's done through citizen science approach, and we do expect to see some systemic bias in data collection. So let's move on. Firstly, I have presented 2 different case studies in Nepal that have been uploaded to the platform. The first one is reforestation and forest protection in Nepal. So what the article says is that these programs are increasing the carbon stock in forest and acting as a carbon sink. It has societal benefits that include providing fodder for livestock, providing fruits and vegetables that the villagers can sell, etc. And importantly, it's contributing to the United Nations RED Plus program through reduced emission through deforestation and forest degradation. Moving on to the section on the right, we're presenting slope stabilization using brush layering in Balefi in Nepal. So it's a hybrid intervention with mix of gray solution as well as plantations. It tackles landslides and debris flow, which secures transport infrastructure and allows economic activities to go smoothly. Next, we look at 2 case studies from Thailand. The one on the left is of the rooftop garden at Thammasat University, right next to AIT. So in case you guys haven't had time to go there, visit there from the conference yet, please do. It's an amazing recreation site. But also, it's providing multiple benefits. Here I've just highlighted sustainable food and collection of rainwater. The 4th case I've shown is urban park to collect rainwater in Bangkok, Thailand. So Bangkok is a flood-prone city. It's also known as the Venice of the East because of all its waterways. However, with urbanization, these waterways are being paved, and there's less room for water to go under the ground. So this project looks at collecting rainwater during rainy season and leading to reduction in flood peak. Not only that, during dry season, the water collected can be used for irrigation. Next, we look at statistical summary of entries from Asia. Firstly, we look at a matrix of NBS catalog for each hazard and ecosystem. The key highlights are floods are being tackled in almost all the ecosystems, and various different ecosystem types such as forest areas, river ecosystem, urban and coastal areas, and wetlands have the most number of interventions associated with them. Second, we look at inventory of most common NBS interventions by hazard. Firstly, we shortlisted soil erosion, landslide, flood, and drought as the four most common hazard types being addressed by the NBS entries in the platform. Secondly, various forest-related interventions such as reforestation, afforestation, and optimized forest management were the interventions with highest number of entries. Moving on to conclusions and discussions, majority of NBS entries from Asia deal with floods. That's perhaps because the flood community is very active in NBS, but also because many of the NBSs directly or indirectly deal with floods. And they are implemented in different land use types as well. Secondly, grasslands have very few NBS entries. It could be because less people live there, but also grassland in itself is a nature-based ecosystem. So perhaps it maybe doesn't make sense most of the times to think of NBS interventions in grasslands. Soil erosion, floods, and droughts are the major hazards found in the Asian region in the GeoIKP. This makes sense again because we are mostly dealing with the changing climate, and these are the key climate risks that we see with the climate extremes. Fourthly, most notable insight perhaps is a possible desensitization of heat waves that we found through the database. Overall in the database, we saw a very large number of entries related to heat waves, but maximum of them were from the European region. If we look at the Asian region, there were only 2 entries. However, heat waves are very common in the region. If we look at the heat wave of this summer that affected the whole of the northern hemisphere, yes, it affected Europe, it affected Northern America, but also it affected many parts of northern India and nearby regions. But maybe there is a desensitization in the region when it comes to heat waves, and we don't look at it as a hydrometeorological risk. Next, niche hazards such as avalanche, wildfires, etc. are poorly represented. Again, perhaps many of them do not have appropriate NBS interventions. Avalanche pretty much is a impact event. And also maybe because these are niche ecosystems, there are less interest in the NBS community in these land use types. Next, moving on, there could perhaps be a case for involvement of non-hydrometeorological risk into the NBS framework, especially from the perspective of disaster cascades and multi-hazard. If we look at hilly terrains such as in Nepal, often it's not just one disaster, but disaster cascades. Floods trigger landslides, which lead the roads blocked, but also the region is seismically active. So perhaps we need earthquakes and non-hydrometeorological risk in general to be included into the operandum framework. And lastly, most of the entries in GeoIKP was from the European region. This is because it initiated from a European project. But as much as this tool is working well in its current state, its promotion in Asia and other regions is critical for it to be more representative throughout the globe. And these conferences with academics, policymakers together are perhaps best places to reach out to people and to promote these tools that enable replication of nature-based solutions from one region to another, and so forth. That's all for the presentation. Acknowledgements. The work presented here is based on Operandum project funded by the EU, grant number 776848. And we also thank the organizers of the conference for supporting financially participation in the conference. These are my key references, and that's all. Thank you.
Thank you very much, Mr. Amin Sakya. So please return to the table. And moving on, may I invite Mr. Ahmad Rashid from Indian Institute of Technology, Patna, who will share with us his research on a geospatial technique for evaluating the efficacy of blue-green space for flood mitigation. The floor is yours. Thank you. Just a quick reminder to all the audience, since we won't have Q&A intermittently, so please do take notes and give your questions to the respective presenters at the end of the section. Thank you very much.
Hello, am I audible? Good morning, everyone. My name is Ahmed Rashid. I'm here to give a presentation on the topic use of geospatial technology to analyze the efficacy of blue-green infrastructure in mitigating the flood risk in a metro city in India. So India is one of the most flood-prone countries in the entire world. Actually, last year, many studies concluded that most of the population in India, it is prone to floods, both riverine and urban in nature. And this is primarily because India has a lot of rainfall variability. It receives most of its rainfall during the southwest monsoon, the average rainfall which is around 850 millimeters, but which varies from north to south. So I'm going to discuss about urban floods. Now, urban floods, it's a new category of floods which has come to rise because of rapid urbanization, especially in a developing country like India, where population is very, very dense, and urbanization, it is mostly unplanned. So in 2008, the apex body for managing disasters in India, the NDMA, it delinked urban floods from riverine floods, stating that the cause of urban floods is significantly different from those of riverine floods, and so we need to have different strategies to deal with these floods. So in the recent years, city after cities, they have been flooded in India, and hence it's a big challenge for town planners to deal with this issue. Now, urban floods, they are caused primarily because of anthropogenic and climate-induced reasons. So because of urban expansion, the impervious area, it increases, which leads to quick buildup of runoff. And these runoff volumes, they are quite high compared to non-urbanized areas. Also, in a recent report by the Ministry of Earth Sciences, they concluded that the wet spills, they have become more intense. So what they were trying to conclude is that more of rainfall, it was happening during the number of dry days, it has increased, which has led to a reduction in the wet days. Also, the frequency of localized heavy precipitation events, it has increased. So we need to assess the risk of flood in urban areas. And in this study, we are going to use geospatial data to do this analysis. We are going to implement the blue-green infrastructure, as has been discussed by the previous speaker. So we are using this analysis over different models because the data, it is easy to visualize. We have easy access to this data, and we can visualize how effective these solutions are in mitigating the flood risk in terms of runoff depth. So we have taken the study area as Hyderabad city in India. It is one of the most populous city in India. It's the 5th largest urban economy. And in the October of 2020, there was heavy rainfall, which led to significant urban flooding in most of the city. It led to a huge loss of life and property. And to make matters worse, there are studies which indicate that the rainfall intensity, it will worsen in the future based on different RCP scenarios. So keeping in mind all the discussion, we have certain objectives of research. We want to first have some data, because research, it begins with data. So the lack of hydrometeorological data in the study area forced us to use synthetic data sets. So we will establish how relevant these data sets are. Further, we will study the role of geospatial data in the context of our study area. And then lastly, how effective the blue-green interventions that we are proposing are in reducing the flood risk. So, in the methods, we have basically used the National Center for Medium Range Weather Forecasting's reanalysis data, which is available at a grid of 0.12 degrees. And we have compared this data with the ground-based observations that we already had. So, based on the results, we have selected certain data points, and we have made a consolidated rainfall data set. Then we have implemented the curve number model. So the curve number model, it's the heart of most of the hard-looking models, such as SWOT or HMS. It basically converts the input rainfall into runoff based on a dimensionless parameter known as curve number. So this curve number, it in turns depends on land use, it depends on the soil group, and on the rainfall which has taken place in the previous 5 days. So then we have, after we have found the curve number for the study area, we have corrected the curve number for slope and AMC conditions. And then we have incorporated different hypothetical conditions of blue and green infrastructure to find out exactly how these runoffs, they will be compared with the original runoff. So in the data set, we have taken 20 data points around the city, and we have carried out tests for normality to establish the normal distribution. So and then we have carried out the Pearson correlation on these data sets. So it left us with around 12 data points for ground-based observations, and we compared them with the IMD data sets. So the stations which had fairly good results are shown in the table. If we take a look at the land use pattern in the city, we can see that the city, it is very, very densely built up. There is almost no sign of green in the city. The green area, it's only 1.7%. So the questions that we asked was that what if, let's say 10% of this built up, it was given to, let's say, vegetation, or if 20% was given to blue infrastructure. So what the scenario or the situation would be like in the runoff which is being produced. So with this thought in mind, we have done this study, and if we take a look at the population density, it is exceeding 10,000 in almost all the different wards. So the wards, they are different administrative units in the city. If we take a look at the rainfall map which we have prepared for the actual flood event using the different rainfall data, we can see that the rainfall, it is pretty high, and the resulting runoff, it is also pretty high. So the red regions, it represents the high runoff values. Now, if, as I had previously mentioned, what if the urban areas, they had some amount of vegetation, if they had some amount of blue infrastructure, let's say recharge pits or recharge trenches to tackle the incoming runoff, so what would be the situation like? So based on these assumptions, we have modified the curve number to account for blue and green infrastructure using existing literature.
Mr. Ahmad, you have 2 minutes.
Yeah. And coming to results, if we see like based on 50% green infrastructure, the red areas which represent the high runoff, they have decreased somewhat. And if we take into account 30% blue infrastructure, the red areas, they further diminish. So this chart, it basically shows how different percentages of blue infrastructure and green infrastructure compared to no infrastructure at all will result in reduction in runoff. So the runoff, it decreases by almost 12.4% if we have around 50% green infrastructure, and the reduction, it is more significant in case of blue infrastructure, which decreases by around 31% for 30% blue infrastructure. So coming to the conclusion, we can conclude that we can use geospatial analysis to effectively assess the flood risk. Instead of going for complex models, we can easily visualize what the implications can be. We can also use synthetic data sets in absence of ground-based observations, and that nature-based solutions, they are an effective tool to reduce the flood risk. Now, we cannot completely eradicate or do away with urban floods. They are here to stay. But what we can do is we can reduce the risk in terms of runoff, which they are in terms of runoff. And in a developing country like India, it is very, very imperative to reduce the risk because we are more, because we follow more of a reactive approach than a proactive approach. And this study it can also be valuable for urban planners and policymakers for disaster land and water resource management. Thank you.
Thank you very much, Mr. Ahmad. So moving on, I would like to invite Ms. Aster from Addis Ababa University of Ethiopia, who will share with us her insight on climate change impacts on blue and green water resources. Thank you. The floor is yours.
Good morning, everybody. My name is Aster Tesfaye from Addis Ababa, Ethiopia. I'm PhD follower in African Center of Excellency for Water Management, Addis Ababa University, Ethiopia. My presentation is focused on climate change impacts on blue and green water resource in Ethiopian Rift Valley Lake Basin and the case of Meki River's subcatchment. My presentation outline is introduction, data and methods, result in the discussion, finally conclusion. Nowadays, climate change is significantly impacting the regional and the global hydroclimatological parameters such as increasing in surface temperature, fluctuating in rainfall, which is the cause of flood in one part of the country and drought in other part of the country. It's also impacting the cause of landslide and the soil erosion, damage to the existing infrastructure, reducing renewable surface water, groundwater, and its cause of water and food insecurity over the world, specifically in developing country apart to the conflict. So when I come to my case study area in Rift Valley Lake Basin, those climate change parameters such as increasing in temperature, which is the cause of high evapotranspiration of Lake Zoai, decreasing the rainfall, which is the cause of dry up of Meki River during the winter season, decline in water level, stream flow, and the other is indeed in this Rift Valley. So that's why assessing blue and green water in this basin is needed to understand the interaction between blue and green water, to make the balance between human and nature to help develop an integrated approach for reducing water scarcity. Meki River is found at the up part of the Zoai Lake Basin. Its elevation is high in highland and low in rift floor. The drainage area is about 2,241 kilometers square. The land cover in this area is dominated by agricultural land with open woodlands, forest and water. Nowadays it is expanding the irrigation in this area. The data used to simulate the impact of climate change on blue and green water resources is historical hydroclimatological data, which is found from different sources. Future climate data we downloaded and downscaled from global climate model called Couple Model Intercomparison Phase 5, and also geospatial data found from different sources. When I come to the methods, blue and the green water balance is considered SWOT plus. Is the blue color is shown the blue water, which is including surface temperature, lateral flow, return flow, which is commonly known as water yield. The green color is shown green water resource, which is including temperature, evapotranspiration due to increasing temperature, and also soil water. to analyze the impact of climate change on blue and green water resource, we developed the climate model and the scenarios. The SWOT plus model, global climate scenario, is analyzed. We use the global climate model with two representative concentration pathway scenario from coupled model intercomparison phase 5. The SWOT model was forced by baseline scenarios, and also the future window is divided into 3 phases: near, mid, and far future scenarios. So before simulating or analyze the impact of climate change on blue and green water resource, the SWOT plus toolbox model was calibrated and validated by using different sensitive parameter, which is used to simulate the impact of climate change on blue and green water resource. So as this figure is indicating, the figure is indicating the comparison between observed and simulated discharge. As it is shown, the simulated discharge is reasonably the same to observed discharge with the Nash cliffs greater than 0.6 in both calibration and the validation period. So blue water is expected to decrease under both scenarios, which is by 26.7 and 31.9 in near future, as well as 45.8 and 62.8 in far future. When come to the blue water, opposite to the green water, when come to the green water, opposite to the blue water, it is increasing, which is by 7.7 and 8.1 in near future, as well as it's increasing 15.5 and 25.3 in far future scenarios. We also analyze spatially the impact of green and the blue water under climate change condition. As we can see from the figure, the climate change is impacting the blue and the green water resource in different parts of these catchments. For example, if we take under RCP 4.5, in near future, the blue water is decreasing from 40 to 15% in north and west part of this catchment. Under RCP 8.5, it is decreasing from 13 to 40% in north and east part of this catchment. When compared to mid-future, near future, and far future, the far future is highly increasing due to climate change. So the cause of this decreasing blue water is the rainfall in this area is highly decreasing. Compared to the blue water, the green water is increasing spatially also. So in the analysis or the result is shown that the blue water is decreasing due to rainfall, but green water is increasing due to high evaporation from soil surface as well as from the water bodies. Sorry. When I come to conclusion, the hydrological model framework found to be useful for quantifying the status of blue and the green water resource within the Mekki River subbasin. Our result is shown that spatio-temporal distribution of blue water and the green water is under climate condition is revealed. At the end of 21st century, blue water in Mekki River will be decreasing by 48.7 and 56% under RCP 4.5 and 8.5 respectively. Green water will be increasing by 22.7 and 24.4 under RCP 4.5 and 8.5 respectively. So at the conclusion, this result is indicating that under global climate change, this information of blue water and the green water increasing and decreasing is it's useful for the policymaker in local water resource as well as in the Maki River as the whole result. Thank you.
Thank you very much, Ms. Aster, for sharing your insights of your research in Ethiopia. So moving on, may I invite Ms. Radha from Department of Water Resources of Thailand, who share with us projects to evaluate ecosystem service improvements on EBA interventions, case study of Thailand. The case is yours. Thank you.
Hi, good morning everyone. I'm Radha Pasingh-Haseni. Today I will present the approaches to evaluate ecosystem service improvement on ecosystem-based adaptation interventions case study of Thailand. And I'm the policy and plan analyst from the Department of Water Resources or DWR. My presentation will start with introduction, method, result, and discussion, and conclusion. This slide also shows the data gathering during the water sampling in March 2022. And the Division of Conservation and Rehabilitation, Department of Water Resources, cooperate with GIZ to implement the EBA intervention in 2019 to 2020 as the pilot project at Hue Chuak, Khon Kaen province. And then my division, the International River Basin Management, was assigned to do the evaluation in 2022. And we set the 4 working group composed of hydro and meteorology, socio-economic and environmental working group, and this article is the study result of the environmental working group. The approach were based on the concept of ecosystem service index that studied by Loxton and Chube, which calculate from the water quantity composed of river flow and cross-section of creek and water quality, and the ecosystem function that studied by Bonnie et al., including the water quality recommend indicator by Jurgensen and by the guidebook for monitoring and evaluation EBA intervention by GIZ. Then, due to some limitation, the study had to measure water level to reflect the water quantity and analyze water sample, including calculate water quality index or WQI to identify water quality. After that, the potential use of water were linked to ecosystem service. Then the provision service improvement was identified from Thailand was WQI and MRC WQI and water level. The cultural service improvement were identified from turbidity for recreation and water level, and regulating and supporting service improvement were identified for 2 issues: water level function on reducing drought risks and percent reduction of TSS function on TSS regulation. The pilot project was located in the northeast of Thailand, and the data for land use in 2 kilometers radius was gathered by the Hydro and Meteorology Working Group. The highest land use area were field crop and paddy field. Water samples were taken by graph sampling method at the middle of the weir before weir number 1, number 2, number 3, and after weir number 3. The water samples were analyzed for 11 parameters, middle of the weir. Water quality were evaluated by Thailand WQI. WQI for the protection of aquatic life, WQI for agriculture use, WQI for the protection of human health, and turbidity standard for recreation. This is the target value for WQI and turbidity. This slide already described previously. The results show that the set of weir improved the water quality and quantity and quality from before the weir, to after the weir. Water level increased from 0.6 to 1.3 meter. Water quality from Thailand WQI changed from poor to good quality. From WQI AL changed from good to excellent, and from WQI AG still in good quality with the 12% reduction in EC value. And you may notice that the EC value here was peak. This may be due to the contamination from agricultural and villages area that we should investigate more in the future. Info in this table show that a set of weir a set of WQI with the percent reduction of EC and water level can reflect the improvement of provisioning service. And water level percent reduction of total suspended solid can reflect the improvement of regulating and supporting service. Then the turbidity standard and water level can reflect the improvement of cultural service. Then the said approach can be practically applied to evaluate the ecosystem service improvement and wet season should be investigated to verify the applicability of these approaches, and more evaluation of ecosystem health on biodiversity should be studied further. That's the end of my presentation. Thank you.
Thank you very much, Ms. Radha, for your very insightful presentations on the case of Thailand. So moving on to our next presenter, may I invite to the podium Mr. Lê Xuân Tú from Southern Institute of Water Resource Research, Vietnam, who will share with us his research on holistic coastal protection strategies with nature-based solutions for climate change adaptations in deltaic coast. Thank you.
Hello. Good morning, everyone. My name is Tu. I'm from the Southern Institute of Water Resource Research in Ho Chi Minh City, Vietnam. Today, I would like to present the topic about the coastal protection strategy with nature-based solution for climate change adaptation in the coastal area. So you know that another presentation just present about the solution, nature-based solution in the river and the city. Just follow me, go to the sea. So as you know, that's in the Mekong Delta is the lowland area, and now that's the one of the area that affected by climate change and sea level rise. So now have many problem in this area like the salinity intrusion, land subsidence, and sea level rise, especially the coastal erosion. That is serious in along the coast here. So you can see that in the coastal area in the Mekong we have 1/3 the length of the coastal that erosion, and with the around 300 kilometers, and you can see this is the picture along the erosion, the mangrove forest here that destroy the mangrove and the sea dye. Okay, so you can see the mangrove forest that erosion here, and also the sea dye that damage. So there are many solutions also apply in the Mekong Delta, like you can see the gel tips here, and they also apply in the Mekong Delta, and after 2 or 5 years that's the broken, and another like the bamboo fan that also apply to restore the mangrove forest, but the timeline is not too long, and the functioning that is good for restore the sedimentation and also the mangrove forest. And another is the forest breakwater. This is the semicircular breakwater and perforated breakwater. So this solution we apply, but that separate in area, and that cannot make the strategy to break well with the coastal. So here, this is the solution to break the coastal area. Now we move in previous they almost use the gray infrastructure with the harsh breakwater and the groy, and now we move to the nature-based infrastructure with the green structure like offshore breakwater that combined with the mangrove forest, or the bamboo fan with the mangrove forest, or perforated breakwater. So we have this it have a different function. So here we propose a multi-line of the defense for coastal protection. So we can see here that's similar with the Lego. This one, the first one, this is the forest breakwater, and the second line, this is the mangrove forest with the bamboo fence to restore it, and the last line is the sea dye. So we can see when we just calculate, if we have only one the sea dye, the crest of the elevation it is 6.4 meter, and when we combine with the breakwater, the sea dye will reduce 4.7 meter, and when we have the complete the defense three component, the sea dye will reduce to 4 meter. So you know that if we combine on the component, the sea dye, the scale of the sea dye is reduced significant, and also the weight reduction. So here from this we propose the multi-layer defense, the type 1 we can apply for the area erosion, and this area can restore the mangrove forest. So the first one, that is the porous breakwater, and the second, that is this will reduce the high wave, strong wave, and that's allow the sediment to move to here. And the second, this is the bamboo fence, and that will support the mangrove grow well. And the last one, it is the sea dye, and to protect the farmland here. And the type 2 we apply for the area with without the sea dye. Such area they the people they use the aquaculture, so that we call the mangrove and the aquaculture integrated. So we can use this type to also protect the mangrove and also protect the aquaculture pond in behind the breakwater here. And type 3 we apply for the area with we cannot recover the mangrove forest because the mangrove forest is very special and it cannot go well with many environment. So for the like the big with the sandy, we can use the breakwater here and to reduce the weight, and we can nourishment with the sand and mud nourishment, so we can reduce the slope here, and that will dissipate the weight energy. So here this is the three proposed structure solution to protect the coastal erosion in the Mekong. Then the first one is the porous breakwater, to build the breakwater, and the second we can apply the nourishment, the beach nourishment, to reduce the weight and also to protect the mangrove forest. And the last one is the bamboo fence, that is natural material, and the local people can apply this to protect the area with the low weight. So here from three types of the we propose, we can make the based on the way high, the tide terrain, and the area with the mangrove recover, or some area we cannot, so we can propose the strategy here. Here we can apply the offshore breakwater and restore the mangrove forest, and another we can protect the beach with the snail. When in the monsoon, the snail will die and that's move to the beach, and that create natural breakwater. So that's very nice and it's very special in here. And another we can use the revetment and offshore breakwater. That's like this. And go to this slide, I want to introduce the new breakwater. This one we study and develop in our institute. This one did have the main breakwater that is porous concrete block. That's similar with the Lego view. That you make in the concrete factory, and we transport to the coastal erosion and play this along the beach. That's similar with the breakwater, and in the foundation we use the Malaloka crab. That is the local material that will reduce the load for the foundation, and we protect the toe with the rubber mount. So here when we build this create the porous breakwater. And here this is the function of this breakwater. This with the forest, so the porous breakwater, so the weight when they interact with the breakwater, that will reduce the weight, and that also some small weight can transmit it to the coastal. And another function is that allow the sediment. So you can see the sediment can also move inside to the real side of the breakwater, and that's sediment in here. So this one we take the pilot project, and after 4 years you can see this side we can take the picture from the sea dye to the sea dye and to the sea here. So you can see this is the breakwater, and here you can see the sedimentation, and we observe from 2019 to 2022 the sedimentation increased rapidly, and this around 0.8 to 1 meter behind breakwater. So here we also observation the weight reduction. This one, this is the we have the weight transmission through the porous breakwater with the experiment. This the blue line, blue dots. This is the experiment, and the red. This is the observation. So we can see that the breakwater can reduce the weight significant, and here this is the weight energy that's reduced. This is in front of the breakwater, and this is behind breakwater, and so you can see that the weight high in front of breakwater that around the maximum is 0.8 to 1 meter, and when you can see the red here, this is the way behind the breakwater that only 0.2. So this one we can protect the coastal erosion. And for the mangrove restoration, here this is the picture here after we building the breakwater with 2 months, and for 4 months the mangrove can grow, and this is around 1.5 years. This grow maybe 1 meter. As when we grow well, and this can create expand the mangrove belt to protect the coastal area, and also this breakwater we have many advantages for when the mangrove can mature after 4 or 5 years. This breakwater can move to the sea and to expand the mangrove belt, because this you can see that is the block that's like the Lego, and also restore the mangrove forest. So
Mr. Tu, you have 1 minute. Thank you.
And for conclusion, this study we also present the coastal protection with the hybrid solution with the many component breakwater, the bamboo fan, the mangrove forest, and also the sea dye. This means the goals to protect the coastal with the for that's suitable for the lowland area, and the detail of the planning for coastal in the Mekong Delta we also introduce, and the important is the perforated breakwater. This is the new technology, and we also develop and we test in the physical model, and also we make the pilot, and now we get the result from observation, and just this one we want to introduce for this conference, and thank you for your attention. Here this is some the paper we already published in the coastal ocean engineering and coastal management. So if you want to find more detail about this technology, you can access this. Thank you very much for your attention.
Thank you very much, Dr. Lesson Tu. So for this session, we have a very good coverage of techniques and perspectives, covering from citizen science to geospatial technologies to hydromolecular modeling and climate change, and we wrap up nicely with some physical model testing, very underground evidence. So with this, all the presenters have returned to their seat. I would now open the floors for questions and discussions. So audience, if you have any questions, please raise your hand. Our student supporters will give you the microphone, and please direct the question directly to the respective presenters. Thank you.
Yeah, first of all, thank you all for your presentations in this session. And I have a question to the first presenter, to Amin, a question and a comment actually. I'm sure you're pretty aware that there are other databases on nature-based solutions online. And for example, the UN Biodiversity Lab, who has a data set on nature-based solutions for climate change. So is there an opportunity to connect this, to merge this? Because information is out there, but it's becoming more and more fragmented. And I think we have to put things together. So it would be nice if you could comment on this. Thank you.
Hi, thank you for the remark. It's very good, of course. There are other platforms except for ours as well. What we try to bring with our particular platform is this holistic elements with user profiles for businesses, for CSO organizations, etc. But in terms of opportunities to collaborate with other NBS platforms, I'm pretty sure there is opportunity there. This work I presented was when I was collaborating with Kayo Services. So if I think it would be great to get you in touch with Dr. Milan Kalas, CEO of the company, and Project Operandum, like key component developer, and maybe you guys could find some ways to, you know, sync it up. It's a great idea, I think.
Okay, thank you.
Okay, thank you very much for all the presenters. I have a question for the second speaker who was speaking about the green and blue infrastructure for reduction of runoff in urban areas. Urban flooding especially is about rainfall intensity than the volume. So in your analysis, have you considered also how this infrastructure, blue and the green infrastructure, responded to different rainfall intensity causing urban flooding?
So can you please repeat your question?
Have you considered how this infrastructure, green and blue infrastructure, responded to high rainfall intensity, which are causing urban flooding?
Okay. So like the flood event that we have considered in the study, we have taken a very high rainfall intensity event, which actually caused the floods. So when there is very high intensity of rainfall, then even the blue and green infrastructure, they fail to reduce the runoff, because there is already saturation in the soil, in the surfaces, and they are unable to absorb any kind of incoming water. So I might have not explained in the presentation, but like we found this in the study.
First thing. Hello. My question for the last speaker, Dr. Lee. Actually, it is an interesting presentation. You consider the hydrological point of view. Could I ask you about the environmental point of view, especially when we are speaking about mangrove? In Egypt, especially, we motivate grow mangrove at the Red Sea for the point of view blue carbon or carbon sequestration in the soil. You consider the environmental point of view, or just focus in hydrological approaches?
Yeah, for my study, we also apply for the modeling and for the physical model to study about the study about the hydrodynamic in this area, and we know which the area that's suitable with the the structure, and we can simulate before we build the breakwater. We simulate the way and the sedimentation, and we also investigate the area that can grow with the mangrove forest, because you know the mangrove forest that will grow well with the merged, maybe the merged area.
Yes.
Yeah.
Actually, it is interesting. We motivate the world to grow mangrove not only for the wave protection, but mangrove used for the carbon sequestration and reduce the carbon dioxide emission. It is interesting actually to focus in this for the coastal lines, like you mentioned here. Yeah. But my question, consider my advice. You can consider with a hydrological point of view, consider the environmental impact. Yeah. It will be interesting for you.
Yeah, yeah. Thank you very much. This point I will observe and analyze in the near future. We will publish soon. Yeah, thank you.
Thank you. Hi, my question is also for the last speaker. So this session is on mainstreaming nature-based solutions. And correct me if I'm wrong, but I think in your case study you are implementing some really new approaches. So could you explain a little bit about your experience? For instance, how did you get local expertise to construct the measures? What were some of the challenges and how did you overcome them?
For me, yeah, for when we implement this the pilot project, we have investigation, and also we go to the area, and we know the local people. You know, that's for the livelihoods they need the mangrove for the aquaculture, or they need the forest. So when we do this project, the local people, they very happy, because when the mango grow well, that's the aquaculture, like fish or crab, they will restore the ecosystem, diverse ecosystem, so that that's more suitable, and also not only for the concrete, the porous breakwater, but also for the bamboo fence, because when you protect the coastal erosion, the bamboo fence, that's very easy for the local people. They can protect and they can doing it. So this the mango, the bamboo fence, that's very popular for the local people. And when you with the concrete block, that's the government, they should be building this. And for my project, on the local people and also the government, they support our for this project.
Hi, I think, so my question was more like, actually, how did you construct them? So I guess you need to work with like local firms. Did they know how to construct them? How did that expertise get transferred?
For the construct this, you know that this block we product in the concrete factory, right? And when we put it in the barrel and transport to the erosion area, and we just use the crane to play this for the line we design. So it's very easy for constructing, and the time, you know that in the coastal area, that depend on the monsoon. So in the strong way, we cannot construct it. We only construct the breakwater in the clam area. So, but for this technology, we can build a breakwater very quickly. We for 5 kilometers, we can maybe 6 months. That depends on the machine. We can, but it's very quickly for building this. Yeah, and it not affect environment. You know that it another traditional breakwater we can construct with many machine and something that affect the environment. Yeah, for this technology, that less effect to the aquaculture, and also because that almost they create it in the factory. Yeah.
I think we have another question.
Yeah, my name is Lord Smart. I'm having a question for Aster. You look at the impact of climate change on the Mekelle River catchment, on the red, on the blue, and the green. But my question is, did you look at the impact on the community, or how did the community, or how the community responding to the impact that you found on the various resources that are found in this catchment area, if any?
Thank you. Actually, this is from my PhD objectives. In this objective, we didn't include the human response to the climate change, but we have a survey about the human response in that area to the climate change. So in the second research, we will include it. Thank you.
Hello, my name is Paul Pavlik from IMI. My question is to Ms. Radha from Thailand, DWR. I was just wondering, in terms of your case study in Hue Chuak, in Khon Kaen province, what was the rationale or the reason that you chose that area? What was the ecosystem-related problems that led you to choose that site? Thank you.
Thank you for the question. The rationale that we use the pilot area in Hue Chuak because the GIZ do the study together with my colleague from the Department of Water Resources, do the, we call eco SWOT, like the study like the critical critical water basin problem and identify that the Huayshek have the problem of sediment. Actually, before this, they prioritize the area, but after they do the site visit and discuss with the local people and the suitable of the area to do the EBA intervention is end up with this pilot area. And the main problem is the sedimentation problem from the agricultural area that flow into the creek. And then if we did not do the EBA intervention, the sediment will contaminate in the reservoir downstream. Did I answer your question? Thank you.
Thank you. A small question or suggestion for the last speaker. Your constructions out of concrete. Just could you consider to use recycled material like construction waste to build these structures for breaking the waves? Because I know some examples from Germany though, where we use construction waste to build quite similar structures, like for roadblocks and stuff like this. So maybe this is a consideration to even reduce the footprint of your measures more. Just a suggestion.
Yeah, this pilot project, the purpose we want to recycle this, and but up to now they just building for 4 years, and after 4 years when the mangrove that's mature and that can protect the coastal, we will recycle this and put it to further to expand the mangrove forest, because the concrete we design with the high with the 60 MPa, so that's very strong in the sea water, and we can recycle this. That is my purpose, to reduce the cost, and also that's good for the environment. Yeah.
Yeah. Got it. Thank you.
We still doing quite good in time, so we still can take 2 to 3 more questions if there are any from the audience. Thank you. Yeah, perhaps while waiting, let the moderator ask one very quick question to both the first presenter and also user. Like, I think you mentioned about the database for the nature-based solutions, which is quite fascinating. That's also one of my enthusiasm when we keep talking about NBS, but I mean the centralized knowledge has been missing quite a while. So just my curiosity that is there any of the database that either of you have been working on that we have a particular dimension of monitoring and evaluation? Since I think you're taking on the citizen science, so I assume that anything report there, but is there or any like plan to include information related to monitoring evaluation, that how the NBS actually work in the mid to long run? So maybe that can open some discussion for all of us. Thank you.
Hi, amazing question. In terms of the GeoIKP platform, to the best of my understanding, we get the crowdsourced data, and a moderator just evaluates the data, looks at the links, verification links that are posted, how good they are, and either approves or disapproves the post. So in the GeoIKP, we're not doing additional layer of M&E evaluation. Also because when we say NBS, it's really an umbrella term. So we have a lot of interventions around NBS that work in various scales, various regions, and to develop a single consistent M&E framework, I think it's a big challenge. Maybe some other groups have done it, but for our solutions, especially since it's crowdsourced, that we don't have a very standardized format. We want people who send their NBS solutions to us to have the best user experience possible from the end user point of view. So it shouldn't be too difficult for them to fill 100 column Excel sheet. It shouldn't be a 100-column Excel sheet that they have to fill. So we make it as convenient as possible for the end user to send the data, which could mean that there could be some issues with standardization, I think, but maybe some other groups are doing it better. Over to.
Thank you. I've got a question for Esther. Esther, really interesting work in terms of how you've been able to calibrate and validate your model for both blue water and green water. I'm just curious as to where you will take the model to now. Are you going to use that model in terms of looking at future planning for different agricultural practice, or the role of different land users that might perhaps start to change the green water losses in the system?
During the calibration, we used only the discharge values to calibrate and validate. But before that, we did the water productivity, when the water availability, water management in that area in another paper. So in this objective, we include only the discharge by using higher SWAT plus toolbox. We calibrate the discharge by using different sensitive parameter, which is sensitive to that area. Yeah.
Yes, I think, and thank you very much, everyone. And in favor of time, and though I believe there's still a lot of discussions can be going on since it's a very nice topic, but considering of time, I would like to take the permission to close the session here. Again, may I ask for a round of applause for all of our presenters. Thank you very much, everyone. And with this, I close the session on mainstreaming nature-based solutions. Thank you very much, everyone.